And most of the server application languages are also Java. So it integrates well with the existing in IT programming infrastructure. That is the reason why people prefer Python than R. But R can also be converted into application very easily by non-programming knowledge of guy. Anybody can convert your machine learning model into an application, and you can implement it as a intranet application or a web service or an independent web internet-based application also. It's very easy to be done. So that is what happens in industry. Experiment in R, implement in Python. And if the client knows statistics and machine learning, he will definitely ask for the R output also. If the client knows statistics and machine learning, he will definitely ask for the R output along with your Python model with exactly same parameters so that he can check the statistical reliability and validity. So you have to have some interface with R also. So the best is SQL plus Python plus R. Why SQL? Because it's always better to download our own data rather than developer will, SQL guy will give you some data which does not meet your requirement. Then you go back again, ask him. So instead of avoiding all those things, what the companies are doing is they are giving you the complete dump. You have to know SQL to go through the dump, sort the data, bring the data to a table structure, and then you start cleaning it up and doing the machine learning model. So SQL is also required. Preferably open source SQLs. Open source SQL like MySQL or NoSQL or PostgreSQL. PostgreSQL works on very large scale data. But everywhere it is same. Select, where, from, create, update, alter, drop. These words are same. Minor changes in the syntax in the name of semicolons, commas, spaces, that is the only difference, but basic SQL is same across different platforms. But why different platforms? Because they have different types of backend technology that makes the computing faster. PostgreSQL works on large scale data. If you run a MySQL query on a very large data, if it takes 8 minutes to get to the output, PostgreSQL will get it in 6 minutes or close to 5 minutes. That is the only difference. NoSQL, maybe 9 minutes or 10 minutes. That is the difference between the MySQL and NoSQL. So that is the only difference point. So if you are comfortable, you can wait. You can have those simple softwares. If you are having computing power on cloud, which you are paying based on computing power usage, then you want the query to be run very, very fast. So these sort of things you need to have. So SQL plus Python plus R will be the best path for you. That way you can solve any things. And second thing is, you should always remember one thing. Machine learning is all not about building the model. Building the model is just seconds. It's all about cleaning the process, understanding the data. All those elements have to be done. Without doing those things, you cannot go into machine learning. I have seen a lot of people getting stuck, sir, I don't know what to do with the data. They call me. That's the problem is they don't have the practical interface. They do this 3-month programs, 6-month programs. No. By end of the day, my students who are in PJ 17, 18, they are working on real data sets from day one. No training required. Because we train them like that, fully trained. They are working on clients like Uber, Ola, and all those client projects, CBRE, from day one. No training required. They were very happy. That's why they are coming back. Capgemini also. They are waiting. Last week also they did a interview Monday. Yeah, this Monday only. They are desperate for people from here. So, but because our people will work from day one. They don't require any training of any sort. You give them any data, they will work. That's what I create the confidence. That's why I insist on the procedures, the process, and all those things and all. Without knowing that, you can't work on any data. Now, sometimes you might have challenge, you will call me. I will also try to help you with the type of data. Sometimes one guy got data of drone images. Agricultural field, drone images. You know, right? Nowadays in agriculture, they are using these drones to see the crop. So, but our Indian images are different and the US images are different. In US, they have 100 acres, 200 acres. Plot sizes are very big. Whereas in India, it is 1 acre. In a 1 acre, there will be no change in the agricultural growth. In a 1 acre, what change will happen? Nothing, right? But when you are putting 200, 300, 400 acres of crop of wheat, there will be unevenness. Some parts, the wheat crop will grow well. Some parts, the wheat crop will go less. 400, 500 acres, the American drone images. So the challenge is they have to identify which parts of the field the wheat is not growing well, which parts of the field the wheat is growing very well. So they have to segregate the positions from those drone images, so that the farmers will know, and then they will focus on that area. They'll go there and see why the crop is not growing. Does it need more nutrients? It will give them. They will add more nutrients to the water and all those. It's called smart agriculture. Everything is connected. Even there is a data set where French wines, grape things are there. No? There the data is collected or from sensors. The data includes leaf temperature also. What is the temperature of the leaves? It is a small mobile, what you call a robot that goes to the agricultural field and it calculates the data. It has Wi-Fi and GPS and it transmits the data. It keeps on tracking the size of the fruit, size of the leaves, size of the plant, what is the water levels, humidity, temperature, airflow, lot of metrics are calculated. Now, based on these metrics, they have to come up with decisions like how much water to be supplied, what type of nutrients to be given, so that they can save cost on the fertilizers, because fertilizers are costly, right? And the plants are also costly. So they have to be very, very careful. Even in hydroponics, you know hydroponics, right? Without soil, they grow. In Hyderabad also, we have an hydroponic farm. They grow these strawberries, tomatoes, cherry tomatoes and all in this hydroponics. No soil, they'll go in trays, pipes and all those trays and all. So everything is done by machine learning, no human interface. So the sensors will collect the data, see the water level, humidity, accordingly it will on the water, sprinklers and sprayers, and it will fertilize. Now to get the data and actual things, you have to understand the data first. Okay, what this sensor data is telling me, that sort of understanding must be there. Without understanding, you can't work on data. And you will have some very bizarre instances. Last week you work on agriculture data, this week you'll work on retail data. That is what happens. You have to be ready for that also, right? So that is what is happening. So you have to be so if you know the concept, you can implement it on any type of data. See, regression is same, right? Whatever may be the data, multiple linear regression theory is same. The equation format will be same. Whatever may be the data, it's an agriculture data, banking data, telecom data, retail data, whatever may be the data. The fundamental concept, if you have the understanding, you can apply it on any type of data. That is what you have to understand. Applied statistics is what we call it. Applied machine learning is what we call it. You have to apply these concepts on data sets. You have to apply this on business problems. You have to, once you can apply this on the business problems, you will have a lot of utility, which happens in our daily life, right? From your Swiggy, Uber, Ola, they are all run by algorithms, not by human beings. If you allow human beings to run Swiggy orders, there will be at least 10 errors per 100 orders, right? But now Swiggy claims that they have only 1 in 1 lakh. 1 error in 1 lakh. 1 wrongly placed order or 1 wrong, that is also human error only. Particularly to some sets of things they are saying, not to all. Lunch orders, they have 100% accuracy. Some breakfast orders, because of the vendors, they have problem in some regions. Because those vendors don't know English or something like that, they are creating problems for them. I have seen this case of Maggie. Frequently, I see Maggie being wrongly sent. I don't know how many of you order this. We don't have this Maggie wala here, right? We have a Maggie wala. We don't have. Uh, Kukatpalli said somewhere we have Delhi. That said it's famous chain Maggie Wala. They do 100 types of Maggie. Same Maggie, 100 types. Veg Maggie, some Manchurian, whatever say, Sichuan Maggie, all sorts of Maggie they do. Now the person who is doing the chef, if he doesn't understand, what he will do? Whatever based on his understanding, he will do it and send it to the client. Now client orders one thing, he will receive another thing. Now it's not the problem of Swiggy or the software, it is the language problem. Because not all chefs are comfortable with English and all these guys, entrepreneurs, some, bandiwalas and thelawalas, they don't understand, right? They make fruit Maggie also. I don't know, I have not eaten, but Maggie with fruits. Instead of Maggie masala, they put fruit chaat masala and fruits. That is also popular, healthy Maggie, it seems. Guilt-free Maggie. All funny things. Huh? Okay. So this is how we come up with the final number of trees. Now let us see RF model dot score x comma y 94.09. Okay. Cross validation to check whether there is any overfitting x comma y. So you are started working on your GitHub things. Any projects you have uploaded till now? GitHub projects. So you have to upload data pre-processing. BigMart is already done with 3 models. Add some analysis to it. Write some your understanding or model understanding and all. Upload them, na? GitHub. IPNB file. Download the IPNB file. Create repository, and then you can just upload the IPNB file. You can upload till model building also. Na? We are for the same EDF things. We are done till model building. Add couple of your own interpretations to it. So you see, whenever you're uploading something to GitHub, you should also have some notes written there, like the concept or what you have done, so that you can remember and explain it to the recruiter. Okay, you have done a missing value imputation. What type of imputation you have done? You write down one line. Imputed with mean, imputed with median, because mean is distorted. Like that, you have to write one-liners. Now that will help you to answer the questions. They will ask you what type of imputation you have done and why. I have done a median imputation because mean is distorted. There is a big difference between mean and median. I have done mean imputation because there is no distortion between mean and median. I have done a most frequent or mode imputation because it's a categorical variable. Even though the data is numerical, we have to treat it as categorical. So I have done a mode imputation. They'll ask you what is label encoding, get dummies. So they will ask you certain concepts also, which are related to you, what you have done. Oh, this is also overfitting, huh? 55, 59. No, random forest is also overfitting. 57 average. So the data is very small, 8,523. So random forest sometimes overfits on smaller data. It requires typically data above 30,000 observations. So that also is one thing you need to remember for random forest. It requires large scale data. The more data you give it to her, the more chances of its prediction are there. Here also, if it is overfitting, the only option we have is max depth. See, this is a common question. How do you control overfitting in tree-based models? By controlling the depth of the tree. Depth means how many levels the tree should grow. So max depth of the 8, we got 65. So cross sell score, I think, will be now good. See, now it is good. All of them are closer to 60%. Can we increase the trees? Because the more number of trees, I'm doubling the trees. Because the base assumption is by having more number of trees, will the accuracy, will our R square increase? That's what we are going to check. If it doesn't increase, that means the previous 1000 trees are enough. There is no change. The variance or the error plot is not going to show us any change. I think 65, 64, same. Not much of a change, even if we double the trees.
So will it work faster in Google Colabs?
See, Google Colab, it might work faster. But what we are seeing in Google Colab is sometimes those servers are also very far because a lot of people are using it nowadays. Machine learning utility is also increasing. Sometimes Google Colab is also slowing down. So even it is happening with Kaggle because they have 13 GB RAM. Only thing is we should have more than 20 Mbps internet speed, or they said 8 Mbps also is okay, the minimum internet speed. We have tried it on Colab, but we didn't see much of a difference. We will work on one data set called Black Friday sales. I think in most of your laptops, you'll get memory size error for that because the train data is around 5 lakh and the test data is around 3 lakh rows. Variables are less, but rows are very large. So for that time, we have to use only Google Colab. We'll see how it will run. It runs for some laptops, and Google Colab also is giving error these days. Earlier, in Google Colab, we never got an error, memory error. Nowadays, in Google Colab also, we are getting memory errors. We'll work on the Black Friday sales data. It's a very large data. Train data itself is around 5 lakh 50. Test data is around 3 lakh something. So total data is around 9 lakhs. Rows. Variables are around 14 or 15 or something like that. Variables are less, but the rows are very large. Black Friday sales. You know Black Friday, right?
Yes.
The Friday that what you call that one? Thanksgiving. For the December Christmas, people buy na Black Friday. After the day after Thanksgiving. So we'll work on that data, Black Friday sales. Cross validation means repeatedly testing the model. On repeated testing, the model R square or the model accuracy must be closer to the trained model accuracy. When I say closer, plus or minus 5% or plus or in some cases plus or minus 8%. That is what we look at. Some people say, some textbooks say 10% is also big difference. It has to be single digit only, like, because it cannot be exactly same. Plus or minus 5 to 8% is what we look for. So upon repeatedly running the model 5 times, there is no change in data here. The data is same, model is same. We are running it 5 times. When we run 5 times, we are subsetting the data, creating 5 random samples. That means we are altering the rows. So what happens in cross validation is randomly alters the rows and creates 5 subsamples. And it runs the data with those 5 subsamples. And then when you have this, it is like testing. In software testing, we have it, right? We repeatedly test the software with different scenarios. Right, software testing, right? Same thing here. We repeatedly test here with subsets of data, same data. How do we create subsets? Random sampling. Best is random sampling. In some subset, row 100 should be on top. Some type subset, row 100 might be at 2000 location or 3000 locations. The values will not change. The positioning of the rows will change. So when you have these combinations changing, your model also performs in a different manner. Because if it is a tree-based model, Gini and entropy will change, right? So that is what happens. So if you look at the basic structure of cross-validation, model selection, cross-validation and score. See here, it will create groups of data, n samples and features, and then it will. So see here, the splitting strategy. Default is 5-fold cross-validation. Default is 5-fold cross-validation. Now you might question, what is this 5-fold cross-validation? Is it explained here? No. Actually, it is called K-fold. I am using 5-fold. So this is the procedure. So shuffle the dataset randomly, split the dataset into K groups. For each unique group, take the group as holdout or test dataset, take the remaining groups as training dataset, fit a model on the training set and evaluate it on the test set, retain the evaluation course and discard the model, summarize the skill of model using the sample of model evaluation scores. So once you split it as 5 folds, let's say you have split it into 5. Okay, 5 randomly shuffled data. On data 1, you keep it as test data. You build models on remaining 4 data and you use this test data to test on remaining 4 data. You'll get the cross-validation scores. So one set of data is holdout as test data. If you say K is equal to 5, on remaining 4 models, you will train the model. And you will also have the whole trained model as a reference point. So you'll have 5 values coming in your data. So that is the procedure of fold. Now there is one more called stratified k-fold. There are different k-folds. Stratified k-fold is there. We will study stratified k-fold later when we do neural networks. When we do neural networks and all, that time we will study stratified k-fold. That is even more complex sampling procedures. But see, that as we go into large scale data sets, we have to use these sampling methods very carefully. Even these type of sampling methods will create problem in our validation. The basic sampling method is k-fold validation, cross validation. Stratified k-fold, there is something called left out or leave out k-fold, lot of things are there. But the basic version is k-fold cross validation. By default is 5. By default is 5. If you don't give any number, it takes it as 5. Or else you can add a command argument called CV is equal to 3. If you want only 3, CV is equal to 3. CV is equal to 2. It is a trick actually. If you think, CV5 is giving you too much of distortion in the cross validations, we reduce it. CV3, 3 will make it. Then it will be smaller range. Then we can convince the client easily. So all these tricks you will learn once you go to industry. So sometimes we only give CV is equal to 2. So that we know if we run CV5, it will give you large deviation, right? Now client will question why there is a huge deviation. To shorten the division, one of the cheap trick is CV is equal to 3. That way you will get lesser range, right? Some people use CV is equal to 10 also. To say, we have done it multiple times, 10 times, obviously there will be large deviation. So it depends on how you want to take the model. But these sort of decisions you have to make, whether I should have 5, 3 or 10, based on your output on the model, you have to decide. Okay, but this is the procedure. Okay, hold on. One data set is hold on. And remaining, you build the models and you will use this test data to calculate the test accuracy or R square. This is the procedure for k-fold. So I'll add it to the here only, right? You want this? Shall I send it in mail or you will take it from the notes? Okay. Right. This is the methodology of k-fold cross validation. I think on the other model, we have built the model, right? Analytics with we have done random forest, right? It ran for too long, right? But we got the output. We didn't get the output for random forest. So all of you have this Big Mart sales data notebook fully done. Huh? Download the IPNB file and open your GitHub. If you don't add, if I leave it to you, you will not add. So let's add that to your GitHub. Okay. Big Mart sales, download it as an IPNB file. Yes, yes, I told you now. From only my specific algorithms are multiple linear regression, binary logistic regression, and neighbors for classification. Rest of all algorithms are both regression and classification. Yes. Only three algorithms are exceptions. Multiple linear regression, binary logistic regression. We will also study one algorithm called naive Bayes. Naive Bayes is only used for classification. Naive Bayes is purely based on conditional probability. It's purely probability based theory. Naive Bayes algorithm will be run only on classification. Rest of all algorithms, decision tree, random forest, gradient boosting, support vector, KNN, neural networks, they all require both regression data and classification data. Now, performance as a regression for some algorithms like KNN will be questionable. They might have very bad performance as regression. It works as regression model also, but its performance will be bad. So generally people say KNN should be used only in classification procedures. It can also work on regression, but the problem is its accuracy levels will be lesser. That is what. So CART techniques, classification and regression techniques. RF is both regression and classification. Tree-based models, all tree-based models. You will see in Azure or in AWS also extra trees classifier, which is nothing but a random forest only. Slight difference to the random forest algorithm. This extra trees classifier there. There is something called voting trees classifiers. So these are being developed. Basic algorithm is random forest. Minor changes to sampling method. Minor changes to how it computes. The calculation. Other than Gini and entropy, they might use some other newly developed metric. Like that, there will be minor changes. Other than that, it will be the same. You can just log into your GitHub using your Gmail. So suddenly the placement lady will come and ask you to email me your GitHub links. Because the Bombay guys will ask you suddenly email the GitHub links so that they want to see how much you are ready for placements. Okay, how are you going to GitHub? Create repository. There is login, sign up, sign in. Oh, I have already uploaded bookmark request. If you want, you can add some exploratory data analysis using graphs, pie charts or something. If you want, you can do that. Because I think PJ17, they have done these graphs and all. They wanted a full project, so they are done with some exploratory data analysis. The regression theory. See, always keep some basic theory in your GitHub book so that you can refer to it while the interview is going on. So when you have this, what you have to do is, I went into the notebook. So repositories. So where is that one? Hey, where is the create repository here? Hmm? That's what, plus button. New repository. Because it was big to the screen, no? It was not able to see. Click on new repository and then see, give a name, right? Whatever data project you would give a name. And then you can add a read mob. Okay. So once you create a repository with a name, you have this upload option. Import coda. No. Where is the upload option? Upload an existing file. And you just upload the IPNB file. Just give the name Bigmart sales or something. And once you create the repository, you can see quick setup below, you can see upload an existing file. Upload the IPNB file. Okay, then once you upload the existing file, you can see your data IPNB file with all your outputs, everything neatly formatted into the data. Your outputs are also same. Your nodes, everything will be saved into that. So everything will be clearly saved. Got it, all of you? Okay. Now you can add this also to your LinkedIn projects. You know, in LinkedIn projects are there. There's this project segment in LinkedIn. So in you all have your LinkedIn profiles. In LinkedIn, you see the projects. In the projects, give the same GitHub project. Okay. As you work on advanced projects, you will delete the old projects and you'll add the new projects. That's what we will do. Okay, GitHub, as many projects you have, the recruiters will be happy. The variation of projects, how many are done, what analysis you have done. That way, your chances of recruitment will be very good. Okay. If you are not comfortable in explaining all the 10 projects, only keep 4 or 5 projects in a GitHub. Okay. If you are not comfortable, keep only 3 projects. One regression project, one classification project, and one NLP or time series project or image processing project. If you can go up to 5 projects, better. One regression, one classification, one natural language processing or text, one image processing, one IoT or time series. 5 projects you should have in your GitHub. And whatever you have done in that, you should be able to explain to the recruiter what you have done. Otherwise, they will simply say that copy the code. To avoid that, in the same GitHub projects, you write the notes. Before uploading the project to GitHub, in the same Python notebook, write your short notes. What is multiple linear regression? Write what you understand in your own lines. 3-5 lines, add your notes. What is decision tree? Add your 5 lines based on your comfort level. You can add 10 lines also if you are comfortable. So that you can just refer to it and you can just explain it to the recruiter. They will simply ask you questions, what bigger projects you have done, explain me this project. They will say, okay, open and show the give them the URL to them. They will come and say, I have seen this project in your GitHub profile. So I want you to explain in detail what you have done. When they ask you the question, first thing you should tell is what is the business problem? What is the objective? What is the objective? Like predicting item outlet sales given the independent variables. Then we talk about exploratory data. I have explored the variable using descriptive statistics, data visualizations, and data aggregations. Talk for 2 or 3 examples. Then you talk about data pre-processing. What missing value operations you have done, why you have done that mean or median, or why you have used algorithm, as you go use algorithms. So like that, you have to explain the data pre-processing. Then you choose model variable. Which models you have made, comparison of the models. There are same models. MLR asks you. Decision tree asks you. And RMS. Create a table and put it there. Or put it there in the cell only. What is the R square for MLR? What is RMS? What is R square for decision tree? What is RMS? What is R square for random forest? What is the RMS? So you can explain them. I have these models. These are the things. According to this is the best. Simple 5 minutes, not even 5 minutes, 5 minutes maximum they give you. So, research objective, exploratory data analysis, data pre-processing. If you are comfortable with hypothesis testing, talk about one hypothesis test if you are comfortable. Otherwise, ignore hypothesis test because I have seen students messing up with hypothesis. They get confused. They make it confused. We get null hypothesis, why, all those things. If you are confident, talk about hypothesis. Or else go to model building and explain and say, okay, you are used MLR. Tell me what is MLR. To give the explanation of the equation first, then explain the relationship between linear dependent variable and independent variables 3 times, and you will be given not more than 5 minutes. So you should cover all the steps in 5 minutes. If you cover this, you will be given an also very 100% time. So that is how you have to make short notes. You have to make your comfortable level of 3-5 line short notes. Take those lines from my notes only. Whatever I am doing, take the lines from me. Just shorten it even further. Because you can't explain the whole theory, right? In an interview. So just pick up the lines what I am giving there, put it in your GitHub notebook, add them so that you can refer to them and explain. That way you will be there, right? You will be seeing the same GitHub notebook only. It will be easy for you to explain. That is the thing you need to understand. They will ask you what competitions you have participated, what hackathons you have participated, what is your score, and you should be always in top 1,000. Right? Anything beyond that will not be considered as a good. If you are in top 1,000, that table advance also prediction. We will work on that later next week. If you getting into top 1,000 itself is a very big challenge. If you get into top 1,000, they will simply ask you what you have done, you explain the model to them, they will. Because the competition that data is so complex, getting into top 1,000 itself is a big challenge. So that type of hackathons. So you just keep your hackathons profiles also, which hackathon, how much score, what you have done. That all helps you to get your increased package. People who have done hackathons community get at least 1 lakh more than the average in capturing case we have seen. 3.2 is one person who has just done what I have taught them. But people who have done hackathons and competitions, they have been offered 3.8 to 4.2 lakhs. Same batch, previous 17 only. They are all very captured. And people who are into hackathons and this, they are immediately put on flight. They transfer that girl immediately to Bangalore, put it on Ola course. Go to Ola, she's working last 3 months in Bangalore, Ola flight. She's getting her incentives also. So it will be very easy, simple. So thing is, you have to go beyond it, right? So prepare yourself, that would be the best option. So better write down the short notes, which you are comfortable with. You can copy paste of the notes, share here. Those lines which you can easily explain. All right? So all of you uploaded in the GitHub, right? So please maintain your GitHub profile. We have uploaded a regression. Classification, if you are happy with the analytics, with the HR analytics, you can upload that. Or would you guys want to work on this week's hackathon data? I told you, we will work on that data. I've already sent you. No, I have not sent you the data, right? Smart lead scoring engine prediction, classification problem. I think I gave PGA 20 guys are working on this. Send them on Monday only. PGA 20 guys are working. Let me copy the data. So I've sent it. Okay. So the problem is this. Let me show you the problem description also. Today there is football hackathon. Football data. Closed. Jobathon. So this is the lead generation thing is there. All of you got the data? Train, test, and sample submission. Didn't get the problem statement. It's a lead generation, social media lead generation. You get the data, right? Social media lead generation data. So ID, created date, campaign variable 1, campaign variable 2, products purchased, sign up date, user activity variable 1, activity variable different user activities, and we have to predict the buy. Final thing is buy. Buy is the dependent variable. You have 39,162 observations are there. 39,162 observations are there. It is given in the problem statement. Actually, I missed the problem statement. I didn't copy it, but somehow it is not visible. It's given in the problem statement itself. So actually, there should be this about thing. Problem statement, I don't know why they removed it. This is the problem statement. Generally, below, between these, we should have the problem statement. So see here, there are two major issues with the data set: missing values for product purchase and class imbalance. Imbalance means too many of one variable in the dependent variable. So to tackle above issues, he has tried fill product purchase to 0, where sign up is null, and rest to 1. Boosting models like XGBoost, CatBoost, they have used it. And he has got it. So buy is the variable here. Buy is the variable which you need to predict based on the other variables. So here, predictions for buy. This guy has implemented random forest classification. Most of them are data science students only. Kaggle is there. Huh? Smart lead, same thing. Huh? June 2022, right? Where is it? Jobathon, right? So you have the link? Yeah, just send me the link once. Hmm. So all of you can see this. You zoom in. Oh, too much of zoom out. See here. See here. It's you can read here. Now, as a data scientist, what is given here? Want it to be zoomed in. Here. Intention. Intention. Propensity is an economic word or marketing word. Intention to buy, we call it as propensity score. This is how you are all contacted, right? In Ematicus, you might have clicked on the ad in your Facebook or Google or someplace. Same thing, lead generation engines. We have this Salesforce is very popular. Salesforce is a very popular social media lead generation site. If you or Google Analytics, right? You have this Google Analytics. If you connect your campaign with the Google Analytics, you will know which user, his email ID, his user profile, his Facebook ID, his LinkedIn ID, all those things are captured, your locations, your age group, your interest, everything is captured. Based on that, they will study your profile and then they will call you. Because what happens in this lead generation is 50% are waste rates. Even today, in social media, we have the biggest problem is 50% are dummy leads or waste rates. They are of no use. Okay, so by studying them only, you will understand that they are no use. Some farmer in Assam might also have been clicked on that. What is the point of calling him, right? So the social media campaigns, this is a constant problem. Even Facebook, Google Ads also has the same problem. I ran multiple Google Ad campaigns for my blog and YouTube channels and all, and I find that at least 50% of them are waste. No matter how much you create a profile, what you call, you have to give a profile to the Google Ads guys. Whom should you target? Now you should give him the age group, you should give him the gender, you should give them locations, which countries, people, all those things you have to fill up patiently. Now, if you fill up even though you do it with lot of accuracy, still you will generate 50% dummy leads. So that is why we need a lot of machine learning work is being done on this lead generation. Now, nowadays these leads are manually sorted. Nowadays, these leads are manually sorted by people working in Accenture, IBM, Genpact, and all these places. You have people who go through they offer the service to their clients. Whatever social media campaigns the companies run, the data is given to these outsourcing companies like TCS, Infosys, where people will be going through the Excel sheets, understanding the leads, the spreadsheets, and then they will consolidate the leads which are good and send it to the marketing and sales teams. Now, when you have lakhs of leads, you have to have people running them. You can't expect the sales or marketing manager to go through. If it is only 50 or 20 leads, the sales manager will do it on his own and do it. But when you have very large scale leads, like in this case, we have 39,000 leads, a simple campaign, direct to customer campaign, the D2C campaign, customer campaign. Now, among these leads, understand the lead, and you have to also predict which type of lead will generate the buy. Because companies ultimately want buy, right? Who will buy my product? So you have to build a model that goes through this data. Any data if the manager gives, he will know whether this lead will buy or not. The propensity. Now it is being manually done. Even in Imaticus, it is manually done. The counselors will go through the lead. They will study the profile of the person. If it is matching them, then only they will call. Otherwise, they will not. So using various factors, you have to come up with the buy 0 or 1. Buy 0 means no buying. Buy 1 means yes. All right. So shall we work on this data? Yeah. Import this data. Import the train and test data into. Open a new Jupyter notebook and import the train and test data. Got it, all of you? Any exploratory you have done? Missing values are there, huh? So run the basic comments, head, tail, describe, all you have run till D types. Import pandas as PD. Import numpy as NP. Import matplotlib dot pyplot as plt. Percentage matplotlib inline. Import IO percentage CD single quote. The folder name AE Smart. So, we'll see. So lead we'll take break. Yeah, you can take a break. Just take your break. Okay. We'll work on it after the break. I'll also import and keep it ready so that we can start working. Yeah, done from my end. Dot sort underscore values ascending is equal to false. So products purchased 20,911 missing values are there. lead test dot is null dot sum dot sort underscore values ascending is equal to false. Same columns. Same columns are missing values, right? So same columns in train and test are missing values. So what should we do? We will combine. First we'll combine. We have to do the treatment, right? Same treatment should be done in train and test. Combine them and do it only once. Otherwise you have to do it 2 times. So why to do repetition? Add the by and fill it with the word test. Equate the columns and then combine them. So we will add the column by lead test square bracket single quote by is equal to test. What basically we are doing is we are adding temporarily dependent variable to test data. Why we are adding? To concatenate or combine both train and test for pre-processing. For the purpose of pre-processing, we are adding the dependent variable to the test data and filling it with the word test. Okay. So that we can concatenate both the data frames, because for concatenation, the number of columns should be same and the sequence of the columns should be same. It's there. The number of columns are same. The sequence also is same. Sequence means the name of the columns are also same. If the sequence is distorted, the concat will not work. So what we have to do is we have to bring the data into same sequential order, which is again a real-time problem. So what we generally do is we restructure the data frame with the sequenced values. We'll first bring the train to a or we'll take the train as the thing and we alter the columns in test, which is done using manual method only. Or there are applications in R which will help you to drag and drop and do it. But in Python, we have to do it manually only. We have to restructure the data frame by putting double square brackets and copy pasting the variables in that order of the train data. Thereby we match that. That is the easiest task. Some people write for loops and all, but it's a waste of time. Manual is the best and easiest process. Copy paste the columns in the order of the train data. That's all. In real time, we'll have this problem. If you are taking test data differently from a different database, it will mismatch. If you take both of them from the same database, you will not have a mismatch. Yes, generally we do a 70-30 split. Actually, we take the complete data set and we randomly split it into 70-30 or 80-20 or 60-40, your choice. In this case also, they have done the same thing. They have taken the whole table and did a random split of train and test data. I think this is 70-30 split. Okay. So combine lead is equal to pd dot concat square bracket lead train comma lead test comma axis is equal to what? 0. Row wise concatenation is 0. Okay, so products purchased, it's float 64. What is this column, products purchased? Let us understand this column. What is the data description given? Here is the hackathon. So products purchases, number of past products purchased at the time of dropping out the lead. So it's numerical data, number of products purchased. Okay, so we have to do describe. Combine lead dot products purchased dot describe. Oh, I think we have to treat it as categorical. Number of products purchased, we have to treat it as categorical. See, why I am saying critical, one is min is 1, max is 4, median is 2, 3, right? They are looking at a categories. Number of products purchased is 1 product purchase, 2 product category, 3, 4. So combine lead dot products purchased dot value counts. What happened? Nothing. It's working. And so what should we do with the missing value? What is the total data size? %, missing values. Significant amount of missing data is there. So shall we make it 0? That means we assume that they have not made any purchase. So shall we fill the NA with 0? Okay, we will fill the NA with 0. If the 0 model works, we'll keep it. Otherwise, later we'll do a mean or median imputation. First, we'll assume that the null value means that customer has not made any purchase. So we'll fill NA with 0. Agreed, all of you? So you want to do imputation. What imputation will you do? Yeah, mode means you have to impute it with 2. If you add 29,000 observations to category 2, it becomes very large, right? See, total observations missing are 29,000, right? If you add those 29,000 to 2 category, it becomes how much? 40,000. That means you are creating a bias, right? You are creating unnecessarily creating a very large class. Most frequent is 2, right? That means you have to replace it with 2. If you replace it with 2, 11,000 will become 40,000. It becomes too much of a bigger class. You are creating a bias. So what will be the safety assumption here? Safe assumption is if there is a missing value, customer did not buy any purchase. So we will impute it with 0. No products purchased is 0. That way we will eliminate 0. Your argument is right. Less than 70 we can do. But if you impute with 2, you are creating a bigger class, right? You are assuming, you might be assuming something which did not occur. You might be. I'm not saying it is. I'm using the word might. We might be assuming something which is not true. which is even more dangerous, right? Which will hamper our model. So to be on safe side, let us assume those missing values are where people did not make any purchase. To some extent, that looks as a conservative assumption. So combined lead dot products purchase is equal to combined lead dot products purchased dot fill NA 0. Assuming null values means consumers did not make any purchases. Okay, that is the assumption I am making here. All right, all of you got this? All right, all of you are done till this point? Now, let us see the next missing value columns created at and sign up date. Created at and sign up dates are basically date columns, right? Created at and sign up dates are date columns. Created at and created as no, they are date columns, na? It doesn't have missing values, I agree, but I told you now we have to work with date as a separate thing. Sign up date, before we work up, let us convert it into date, right? Then only we can work on it. Are date columns but showing as object columns, right? what we have to do? We have to convert them into date time. PD dot to underscore date time. We have to convert them, right? You always convert date columns to date time. Okay. Now combine lead dot created at is equal to PD dot to underscore date time combined lead dot created at comma errors is equal to coerce. So errors will coerce will implement NA. If it is finds any missing values or anything, it will impute it with NA. Combine lead dot signed up date is equal to PD dot to underscore date time combine lead dot sign up date comma errors is equal to coerce, right? All right, you have converted. Now find the missing values in sign up date. Only that column. So sign up date, we have same number of missing values. 28,000. Prior also 21, right? It will retain the same missing values, 21,000. So this also we will fill it with 0 only. On the projector, no? You want it? Okay. Hey, if you do direct subtraction, we can do days between created and sign up as a variable, right? We can create a new variable as a difference between, I told you, na, when you have 2 dates, you can calculate difference. How many days between created ID and signed up date? We can calculate, then we will get the date as a days, number of days, and then we can relate both the date columns. Or we can also extract some other information from dates. You remember dates? We can do a lot of things with dates. Dates, feature extraction. This is a very important thing you need to understand in real-time data science also. Date feature extraction or variable creation. So for this, the dates must be formatted. The first thing you have to do is dates must be formatted into date time ns, right? ns, date time ns, nanoseconds. Ns means nanoseconds. 64 ns, right? 64 bit. So when you have 2 date columns, I told you we can calculate the difference. We can calculate the difference between dates as days or months or years, depending upon the data you have. Here we have daily data. So we can convert it, calculate the difference as days. Now, once you calculate days, it becomes what variable? It becomes a numeric continuous variable. Then that is more important for our analysis, right? It will become a more important variable to our analysis, right? So when you can do this, 2 date columns are there, always try to calculate the difference. That is the primary strategy. Second, extracting weekday, month, week number, year, quarter from week. You can extract what day of the week it is. Is it Monday, Tuesday? Based on the date. Based on the date, you can extract what month it is. Based on the date, we can extract week number. You have 52 weeks in a year, right? What week of the year it is, what quarter it is, what year it is, all these things can be extracted from data. I will show you how to do that. So we will do this pre-processing of dates as our learning in this example. Okay, because we have not worked on dates. So this case study will help us to work on dates. Now, let us see if we can calculate the, I'm worried about the combined lead dot signed up date dot head. So, course, how many rows? 52, 345. 52, 345. So when you did the course, all the null values are gone, right? It filled up with some value. So let us see what it filled up. combined lead square bracket days days between is equal to combined lead dot created at minus combined lead dot signed up date. It's simple subtraction. Now what we got, let me check. Combined lead dot days underscore between dot describe.
Actually, sign up from
Which one?
a bigger value, sign up compared to create.
Okay, sign up first and created second. Huh? Did I do the same thing? 1 second, I made a. Now created and sign up.
There is a value in minus.
Ah, no problem. We got some values in minus. Minimum you'll get something in minus. Yes, some values will be in minus. Max is 2350 days, mean is 314 days. See, it is giving you the dates, days and all, time and all also is there. So this is better interpretation. Done? You guys are done? Yeah, I'm waiting. You can see the date time conversions are all there on. I'm waiting. You guys just run D types on combinedly and see what is the data types of the columns. This days between, what is the data type? Time delta 64. Days, sub days, it is taking as time delta 64. All right, can we move forward? Now, let us look at our data types. Combined lead dot D types. Okay. Okay, please take. Both are sign up dates. एक created है ना? हाँ, the given both same columns, change it, get about correct, re-import the data. Go to the pd.read_cst, re-import the data, because that's all written in the data. Data import. read_cst से लेके run out कर दो. ये first एक connect करो, पहले connect करके run out करो. You have given both the sign up dates. Okay. Now we have seen, we have created a new column which is added at the end. It is showing time delta. Delta means difference. Delta means difference. In mathematics, delta refers to difference. Time delta means time difference. Now we have to convert this into integer. We will do it later. Let us also extract other features. Now, what other features we can extract from this date is, we can extract from sign up date and created date also. Okay. So which column should we use? Shall we use created date or sign up date for extracting? Which would be better? For buying analysis, would we go with the created date or should we go with sign up date? Okay. So you want to go with the created date analysis.
I guess created it even means that when that particular lead was created or something.
Right? Right? Guessing.
Because like when we did this.
See, date of lead dropped. Sign up date of the user on the website, which is better. Created date means when the lead was generated. Or when the customer has actually signed up on your website. Which one is better? Sign up would be better, right? Oh, lead got generated. That is okay. Your perspective is also right. I'm not saying you're wrong. But which will give us more validation in terms of analysis? Sign up will give us, right? Sign up shows intention to buy. Lead creation, we may not know whether the intention to buy may exist or may not exist. Sign up means we are expecting there is some intention to buy. Otherwise, why would the customer sign up? And some customers did not sign up at all. That means they don't have intention to buy. That's what we can assume, right? That's what the business will also say. So we can say sign up date is slightly more important than created date. You can also do analysis on created date also. Maybe if sign up date does not work, we have to go and do analysis on created date also. But what we should try first, I believe majority of us believe it is signed up date would be a better intention to buy. So let us extract some information from that signed up date. See, this is how you have to decide. There is nothing right or wrong here. We have to make some assumptions. Sometimes the assumptions might be right or sometimes they might be wrong. But we have to go with least risky one, which we can put as an argument before client. If client says go with created date, we'll go with created date. Client says go with sign up date, we'll go with sign up date. When he asks us to decide, we will propose, I believe sign up date would be better. If he agrees to it, we'll go with the sign up date. So let us do some extraction of the sign up date. Now from sign up date, we will first extract day of month. You know, right? Day of month. 31 days will be there. What day is of that month? First, second, third, like that. So combine lead, square bracket, single quote, DOM, date, day of month, is equal to combine lead dot sign up date dot dt dot day dot dt dot day. Month, combine lead, square bracket, single quote, month is equal to combine lead dot sign up date dot dt dot month. So if you want month name, it will come in text. If you want month, it will come in numbers. 0 being January, 11 being December. 0 being January, 11 being December. US calendar, not the Indian calendar. Indian calendar is different. April being 0, March being 11. But in India, in US, globally we follow the US calendar, which is January 0, December 11. Then we will also get the year. Combine lead, square bracket, single quote, year is equal to combine lead dot sign up date dot dt dot year. Now dt here refers to date time package. dt here refers to date time package. Earlier it was a separate library. Now it is integrated into pandas. Earlier it was a separate library. Now it has been integrated into pandas. Date time, dt refers to date time. Date time library is a sub library within pandas. Now day of week. Day of week means whether it is Monday, Sunday, what is the day of the week. Combined day of date, square bracket, single quote, DOW is equal to combined day of lead dot sign up date dot dt dot day of week. Day of week. Got it, all of you? Now, head, do the head. Combine lead dot head to see the new columns. 3. We got the, and the end we got the new column. See here, days between, we created a new column. Day of month 24, 19, 11, month 9, 8, then year 2020, 2020, 2021, day of the week 3, 5, 2, Monday to Saturday. Okay, if you get any doubt, you can check it in pandas date time, you will get this thing. So we have created new columns in our data. Now we can delete dates. Now we can delete dates. Dates are no longer required because we have created new columns from the date columns. We have created new columns from the date columns. So we can discard the date columns. Both the date columns can be discarded. Okay. Done. So we have created new, this is how we work on dates, which we didn't do in the earlier pre-processing. This is the date. Whenever you have dates, first thing is 2 dates are there, subtraction. If you have only one single date, extraction. What extraction? Day of the month, day of the week, day of the year, sorry, day of the week, E is month end, E is month start, E is quarter end, E is quarter start, lot of things are there. If you look at dt dot, there are many date related things. Dt dot, sorry, combine lead dot sign up signed up date dot dt dot and tab. See, day name, day of week, day of year, days in month, E is leap year, E is month end, E is month start, E is quarter end, E is quarter start, E is year end, E is year start, right? Microsecond, minute, month name, nanosecond. Then you have time zones. In India, we don't have time zones, but in US, you have Pacific time zone, Central time zone, and you have the UST standard time zone. So you can see time zone convert, time zone locate, week, weekday, week of year, year. So a lot of date, you can extract all these things from date. Subject, first you need to format the date using pd.to_data. Upon pd.to_data only, you can extract these things. Otherwise, you cannot. If the date is object, you cannot extract these features. Now, so we have done with our pre-processing. Now, what should we do? Separate the data. We can separate the data. You want to drop and separate the data? Okay, no problem. Combine lead is equal to combine lead dot drop open brackets square bracket single quote id. IDs we drop, right? Then single quote created underscore at comma single quote sign underscore sign up underscore date comma axis is equal to 1 comma axis is equal to 1. We are dropping ID and the 2 date columns. Oh, we are still do some things now. We have to convert them into integers. So days between we have to convert into integer. Days between we have to convert it into integer. That is converting object to numeric. Here we are converting from delta to integer. So what happens is when you convert object to numeric, then use 2 underscore numeric. Here we are just converting the to integer type, specific to integer type. You want the data from, yeah, int 64, right? Retrain df is equal to combine lead square bracket combine lead dot by not equal to test. Where but for me it dictated. Okay, let me check once. Lead test df is equal to combine lead square bracket combine lead dot by double equals to test. Lead test df is equal to lead test df dot drop dot by comma axis is equal to 1. You know, the other showing is dance between that. Those were there's a laptop is not right in front of the store. Use into 64 here. Ashwin. 64-bit na your laptop. It is converting to into 32. The error was into 32, right? So if you get any time 32 error, just change to 64. It will automatically correct. Because I'm using Mac. Mac does not have 32, 64 like that. In Windows, you have both 32 and 64, right? Now remove that, separate the data, train df and test df, and drop the by. Let. Now we have cleaned the process, we have pre-processed the data, we split the data. Now we are in a position to do model building. Otherwise, you want to do it, you can do some exploratory data analysis like using the average, what you call data aggregation and all you can do. Hypothesis, but I think this data is more of a categorical or binary. We can't do much because we don't have a numerical data also. So doing exploratory here is more of a cross tabulations and frequency counts. Y is equal to lead train df dot by capital X is equal to lead train df dot drop by comma axis is equal to 1. Y and X. What is Y here? Dependent variable. X is all other variables as independent variables. Y is your dependent variable. X is all your independent variables. Right? Now, what is the first model we will build here? What is the structure of your dependent variable? It's a classification problem because dependent variable is in 0 and 1. It's a classification problem. So first model is logistic regression. From sklearn.linear_model, import logistic regression. Logit is equal to logistic regression. So we are going to do the logistic regression. Logit model is equal to logit dot fit x comma y. Oh, we got an error. What is the error? Input contains NaN, infinity or a value too large for D-type float 64. We didn't?
We didn't do that part. Stand up will also have some missing values. We did right.
Sign up date still has missing values, huh? Oh, oh, sure. Sorry. I forgot completely. Before the day and month, let us see combined lead dot no, we dropped the column now. Why do we worry about the missing values?
But still, like when we subtracted those, there might be some.
Okay. Zero missing values. Zero missing values. No, it is saying the float value is very big. DOM, what is the problem with DOM? Huh? In DOM. Oh, sign update DT dot. Okay. For filling up this, we need to have sign update properly done, right? forgot. Sorry, it's my mistake. So we have to do missing value imputation in sign up date, right? I did forgot. I did it, but I forgot. Okay. So let us do the missing value treatment for the sign up date. I have to combine the data frames again. Lead train, lead test, combined DF, value counts, date time, date variables, dates, describe, T types. Then we will do this here. Combine lead dot sign up date is equal to combine lead dot sign up date dot fill NA combine lead dot created date created at square bracket 0. Oh, what an error. What have we got? Okay. Cannot reindex values with duplicate values. Okay. Fill in a 0. Oh. So 0 is now taken it. One second. What did I do in that day? Worked in the night. So what is the sign up date? Okay. So combine lead, what we will do is we will extract the sign up date. Okay. Now what we will do here is combine lead is equal to combine lead dot fill NA 0. Why it is not taking fill NA as 0? Value should be time delta nat or array of those got int instead. No. Give it 0 in caps. See? me check if it works. Unlabeled, unknown label type, unknown. Okay. From sklearn dot pre-processing import label encoder. Y is equal to label encoder dot fit underscore transform Y. Because unknown label type means maximum iterations reached. So max underscore iter is equal to 2000. 5,000. Oh. LBFGS failed to converge. We'll change the solver. So for large data, Saga, solver is equal to Saga. Logic model dot score x comma y 81.8. Okay. So see, all of you, after running all the things, date, week, month, and all, you add a cell where we fill all the missing values with 0. After DT month and all, we have this head 3. Now, after that, add a row and fill NA with 0. Whatever NAs are there in month and all, it will be filled as 0. Before dropping this column. So first run from combine. Combine DF forwards to run. How many of you registered to this competition? You registered that day? You did register, right? None of you registered that competition Javathon? No, you should have registered. Now you can do late submission also. If you register now, you can what you call do the test prediction and submit. Okay, so this is the model building. All of you have done till this point. Then we split the y and x. We label encoded the y because it was showing as object, right? Mixed type. See, by default, the solver was liblinear. By default, the LBFGS, no? By default, what is the solver? LBFGS. Well, it's getting the error. Convergence failed. Remember I talked about convergence failed? Convergence failed means all the coefficients were not able to be calculated. Convergence failed means the model is incomplete. The regression, logistic regression model, the coefficients were not able to be calculated. It is giving us two solutions. One is increase the iterations. Second, scale the data. Increase the iterations. Second is scale the data. Now, can we scale this data here? Because most of the data is zeros and ones. We don't have any numeric columns except the ones which we have created takes. Scaling is not possible. I increase the iterations to 50,000. Still, it is giving convergence warning. Convergence warning means the model cannot be built. The coefficients were not calculated for all variables. Then, if max iterations and scaling is not working, the third option is changing the solver. By default, the solver will be LBFGS. If you go to the scalar and logistic regression, the documentation gives you the thing. By default, solver would be what? LBFGS. Now, for smaller data sets, liblinear will work. LBFGS is liblinear and LBFGS are for smaller data sets. Here it is clear written. Whereas SAG and Saga are faster for larger ones. So I have changed the solver to Saga. For multi-class problems, use Newton CG, SAG and Saga. Multi-class means more than 2 levels. If you are using to predict number of digits, if you are predicting more than 2, it is suggesting Newton CG, SAG and Saga. So LBFGS and liblinear will work on smaller data sets, but our data is big, 50,000 rows are there, right? So we are using solver is equal to Saga. I have used solver is equal to Saga. Then the model has converged. Converged means all the coefficients are calculated. Now, once more coefficients are calculated, we have to do what? Logit test predict is equal to logit model dot predict lead test df. I have predicted on the test data. PD dot data frame logit test predict dot to underscore CSV logit dot CSV. Okay, just give me 2 seconds. Let me just upload the data and see. So logit.csv, open with Excel. Okay, then sample submission. Sample submission, open with Excel. Okay, so we have opened the sample submission, we have the logic. Control Shift, down arrow, Control C, Control V, Control S. Now, it is not taking submissions, my submissions. Submit is not taking, oh shit. They removed my submissions, we can do late submissions also. But I don't know why they removed it. Earlier we can do late submission. Maybe later they will allow us to do submissions. Maybe after 10 days they'll allow us. Let us go. Generally we could submit actually. Okay, we'll wait till we get the chance of submissions, late submissions. They will allow the late submissions also. Then we will check the actual score. What was the score with the competition? Now we don't have any scope of doing the test prediction, but on train 81.80. Now all of you do a decision tree. Let us do the cross validation also. From sklearn dot model underscore selection import cross underscore val underscore score. Cross val score logit comma x comma y. So np dot mean control C control V 81.80. So logistic regression is a good model as of now, because for the train and the repeated value cross validation, the almost similar accuracies we are getting. But I don't know, earlier they used to give us late submissions also. Now they are not giving us. But there will be a problem with logistic regression. I told you, imbalance. There is an imbalance. We can also do balancing also. Retrain df dot by dot value underscore constant. No, 81 is not overfitting, right? 81 is not overfitting. Above 95 is overfitting. 81, 81 is not overfitting, and even the cross validation scores are also very close. This looks like to be a good model, but we have to check it with our competition side. When it allows the late submission, then only we can check the test accuracy. Decision tree. Anybody ran decision tree? Anybody ran decision tree? Just look at the decision tree. Overfitted. How much accuracy you got? From sklearn dot tree import decision tree classifier. Tree is equal to decision tree classifier. Tree model is equal to tree dot fit x comma y. Tree model dot score x comma y. 99 overfitting, right? So still we'll do cross validation and see. Comma x comma y. Oh, it's doing well, right? Even it is overfitting on the repeated testing also we got 95. See, 95. So we cannot say the model is overfitting because both the train and the repeated testing is giving us closer to one another. So decision tree is doing a very good prediction here. I think if you submit this model into our competition site, you will get a good rank. Such models in decision tree are very rare. See, not much difference, right? Train model 99.97. Test model, if you're testing it 5 times, you're getting 95. Point, what is the 4% difference? Not big difference. Let us see. If we reduce the depth to 6. 97, but both are good, right? Ninety-seven, max depth 6. This is also acceptable, right?
It should be below 0.95.
Yeah, if you want below 9.5, then we have to reduce it further. 5. Yeah, no problem. So if you want it below 9.5, and if you are not getting it by reducing the max depth, 97.48, closer to one another. Then I think we can play with min samples underscore split. For min samples underscore split also it is giving us the same. Okay, not much of a change here. We'll go with max depth 5. Right? That should be our better model. And on test data, we have to check, no? We have to actually check it with the test data on the competition side, then only we'll come to know. Maybe on test data, we might get 75 or 76. Because some people have tried, no? They got 75 only on the F1 score on the test data. So let us see what is our AUC here. Area under the curve. %85 of area under the curve. That is also good, AUC. AUC is 85%. Area under the curve. Closer to 1 will be the better option, best model. Area under the curve, AUC. 85%. Now in the box, you can see the small box in the area under the curve. You can see here 85% is a good AAC. Flint classification report, sklearn.metrics, import classification report. Okay. ROC curve you can see, right? See, ROC curve, the value should be as much as possible closer to same range, 0.7 to 0.95. Here it is around 0.85, which is a considerably good score. From sklearn.metrics, import classification report. So we have not predicted it, right? Tree predict is equal to tree model dot predict of x. Print classification report of y comma tree predict. Only recall F1 score is slightly lower, but all other metrics are good. Recall F1 score are lower for minority class. So in Kaggle, check the code. If you can see anything new has been done. Ashish, you just check the code in Kaggle. Anything new has been done. Click on code, you will see the notebook. XGBoost, CatBoost, we will study. We have not done gradient boosting. Na? Monday we will start with gradient boosting. Then we will talk about XGBoost, Light Boost, and CatBoost. Next is after bagging is boosting only. We will talk it in the next class. So you remember this process. If you know this process, you can you can tackle any data science problem. The process of importing, going through, sorting through the variables and all, this process is same. If you follow this process, 99% of the times you will submit in your competition. A lot of people register, but only 10% or 20% people only will submit because they get stuck. But if you remember this methodology and process, you can submit into any data science competition. So we have built a model successfully and we have tested it. We have even predicted on the test data. If they had given us access, I would have tell you the score. What is the score? We'll get the late submissions sometime, maybe after 15-20 days, they will make the late submissions active. That time we will submit and check the score again. But as of now, the models look good, both the decision tree as well as logistic regression. So here we are predicting propensity to buy or intention to buy. Okay, so I have already emailed the notebooks. You can look at them. Online guys, any doubts?
No doubts.
Yeah. All right. So next month also you are expected to do on your own. I will not help you next month hackathon. Or if you are interested, today there is the football hackathon. Today 7 p.m. onwards. Football, most probably they will give that English Premier League data. Achha, they are giving Indian Premier League. Huh? Okay, okay. So you can try it. They will ask you to predict goal scored or match wins, something they will give you. Just if you are interested, just 7 p.m. to today onwards, it will start. But you will have one more hackathon sometime end of this month or beginning next month. That you have to participate on your own and you have to submit it part of your evaluation. Okay, the July hackathon. Right? Yeah. So we will end here and we'll continue in the next week. So next week we'll start with boosting. Gradient boosting, XGBoost and light boosting. Yes.